We're going to try another one where we've got, ooh, don't get caught up on this one. We've got a bunch of different things happening, both inside and outside of the function. And then look, we've got something in there we've got to be worried about. So I'm going to rewrite this function. Y equals -3 absolute value. So our base graph is the V over 1 up 1 over 2 up 2 over 3 up 3 over 4 up 4 from 0, 0. And we have to factor inside the absolute value notation. They're like brackets. So just like the square root sign is like a bracket, the absolute value notation is like a bracket. We have to factor this 2 out of those two terms. Now that 2 is going to stay inside the absolute value notation, but then it'll be x plus 4. So if we don't factor, our horizontal translation is going to be wrong. You will still get a horizontal, in this case it's a compression by a factor of 2. You will get that mark, but then your translation is going to be wrong. Okay, and then we've got the plus 1. The biggest trickster move of grade 11 transformations is hiding a factorable number inside the x. That's as hard as we can get. Okay, and look for it because I will be doing it. You know me. So back to this. We have got the base graph, then we've got negative. We're going to treat that like its own transformation. Then we've got 3, that's a second transformation. Then we've got the 2, third transformation. Then this plus 4, which we're going to do the opposite, fourth transformation. Then we've got a plus 1 at the end, fifth transformation. We've got 5 transformations here. So the first thing we're going to do is the negative in front. This is a vertical reflection through the x-axis. We're taking all of our original y values and we are multiplying them by -1. So it's just going to take your original graph and flip it upside down. If they're off balance early, it's going to be like looking at a kaleidoscope. Okay, so you can see how red has been flipped upside down. Over 1 up 1, over 1 down 1. Okay, next transformation is this 3 outside of the function. It's a vertical stretch. We do normally what you would think, and all of the actions happen on the y values. So if we look at red, the 0, 0 going to stay the same. This, let's go to the right side. 1, -1 is now going to be 1, -3 because the y value is going to get stretched by 3. It's going to get multiplied by 3. This one would be -1, -1. Now it's going to be -1, -3. What happens if I do it on a textbook? Will that be better? Let's try that game. Y'all, it likes the textbook better. Okay. So then we are inside the function. This 2 is horizontal inside the function. We do the opposite. So instead of multiplying by 2, we're going to multiply by 1 over k, which is 1 over 2. So that only happens to the x values. That means that this x value of -1 is going to get multiplied by a half. It's going to get squashed. So instead of being -1 at -3, now it's going to be -1/2 at -3. Instead of being -2 at -6, it's going to be -1 at -6. So you're going to see the blue gets even skinnier because the x values are getting compressed and squashed. Okay. Then we're going to take this graph and we're going to move it horizontally 4 units to the left. If it's +4, we have to do the opposite. So we're going to take all of our x values from blue and we're just going to move them 4 units to the left. And looks like we didn't want to do all of them. We're combining the +1. So we're moving 4 units to the left and then we're combining +1. So we would take 0, 0 would go over 4 units to the left, and then it would get moved up 1. On blue, when's my next nice point? There's my next nice point. 4 units to the left. 1, 2, 3, 4. up 1 right there. And that purple graph shows the combination of the functions. Nice.